Hi everybody, this is the first video of this second chapter, differentiation. In this video, I will be talking about how to find the limits of a function as x approaches a finite number. Okay, now let's look at this graph. F of x is equal to 1 over 2x plus 1. If I ask you to find the limits of this function 1 over 2x plus 1 as x approaches 2, how do we get the answer? It means that when the x value become closer to 2, what is the value of f of x heading to? Okay, now let's look at this function. Actually, we have two parts for this graph. We have two parts since the question is asking about as x approaches 2, right? So I will just show you this part. This is the value of x. This is the value of f of x or y. So now the x approaches 2 from the left hand side. I'm going to move this point, become closer and closer to 2. Now you try to look at the changes of this y value or the f of x value. You will notice that this become closer and closer to 0.2, right? So how about x approaches 2 from the right hand side? Same thing happened. This value become closer and closer to 0.2. Okay, so we know that the answer for this question's limits of this function as x approaches 2 is equal to 0.2 or 1 over 5. If you don't want to write 1 over 5, you can write 0.2, the same thing. But let's say we don't have the graph. How do we get the answer? How do we know what is the value of y that the y heading to, right? Some students might be thinking now, I don't have to look at this graph, right? What I can do is just plug in the 2 over here. I find the value of f of x, which is 0.2, so I can get the limits of this function as x approaches 2. Yes, you can do it this way in this case. This one we call it direct substituting. Limits of this function as x approaches 2. I just plug in the 2 over here. Once I plug in the 2 over here, I substitute the 2 over here. I don't have to write this anymore. 2 times 2 plus 1. Okay, I get the answer. 1 over 5, which is 0.2. This one we call it direct substituting. But not every time we can do it this way. Sometimes we cannot get the answer by direct substituting. Okay, let me show you another example. Okay, let's say I have f of x is equal to x squared minus 4 over x minus 2. If I ask you to find the limit of this function as x approaches 2. Okay, how do we get the answer? Now I'm going to try direct substituting method first. I plug in the 2 over here. 2 squared minus 4. 2 minus 2. I will get 0 over 0. This one we call it indeterminate form. If you get indeterminate form, you know that this is not the correct way for us to solve these questions. We need to try another method. Now, forget about the another method first. Can we get the answer just by looking at this graph? Let's try. You will notice that this graph, we have a hole over here, a gap over here. Why? Because f of 2, now let's try to find the value of f of 2. I plug in here, I will get 2 squared minus 4, 2 minus 2, which is equal to 0 over 0, indeterminate form, right? So f of 2 is undefined. We cannot get the value. This function is undefined when x is equal to 2. That's why you have a hole over here, a gap over here. But it's okay, we still can get the limits as x approaches 2. Now let's look at this graph. This is 2. As x approaches 2 from the left hand side, you will notice that the y, the f of x heading to 4, correct? So how about the x? When x approaches to 2, from the right hand side, same thing happen. The value of f of x become closer and closer to 4 as well. By looking at this graph, we know that the limit of this function as x approaches 2 is equal to 4 because they are heading to 4, right? So how do we get this answer? Let's say we don't have the graph. If we don't have a graph, we cannot refer to this graph. How do we get this answer? Limit of this function as x approaches 2. We know that this is the part that's causing problem, because if we plug in 2 over here, we get a 0. We know that if we have a fraction, the denominator cannot be 0, right? So we try to do something to get rid of this x minus 2. Here I'm going to factorize this part. So I'm going to change the 4 to 2 power 2. Remember, you can change the way of writing it, but you cannot change the value. 4, you have to keep the value as 4. I change this to 2 power 2, it's the same thing. 2 power 2 is 4 as well, same value. But why I want to change the 4 to 2 power 2? Because I want you to see this. A squared minus b squared. Still remember this. We can factorize it using this formula, right? A plus b, a minus b. Now I'm going to use this method to factorize this part. So you notice that I keep copying this thing. Every step I have to keep copying this limit as x approaches 2. Once I substitute the 2 inside, I don't have to write this anymore. X plus 2, x minus 2, x minus 2. Okay, so now you notice that we can do simplification here. Just cancel the x minus 2 and x minus 2 over here. Now we don't have the x minus 2 anymore, which is causing problem to us just now. So I only have x plus 2. Now I'm going to bring the 2 inside here. Once I bring the 2 inside here, I don't have to write this anymore. 2 plus 2. 2 plus 2. I will get 4. The same answer as well. So this is a way how we solve this question without referring to the graph. Okay, let me explain a little bit about this one. This one you are going to learn it in the futures. You will notice that I put a minus sign on the top of the 2 here. This doesn't mean that negative 2. It just tells you that as x approaches 2, from the left hand side. Okay, as x approaches 2 from the left hand side, the value of y is approaches 4, right? So the answer here will be 4. How about if you have a positive sign over here? This means that as x approaches 2 from the right hand side, you notice that same thing happened, the value of f of x heading to 4 as well. If the left, this one we call it left hand limit, or sometimes we call it, or people call it left-handed limit. Oh, sorry, left-sided limit. This is right-sided limit. Okay, this is equal to 4. This is equal to 4 as well. This is left-sided limit. This is right-sided limit. Or sometimes people call it right-hand limit, left-hand limit. If these two is equal to each other, as x approaches to a certain number from the left-hand side and right-hand side, the value of y heading to a same number, then the limit exceeds, which is in this case. You will notice that here we don't have a positive or negative sign. It means that from both sides. Okay. Now, how about sometime the left-sided limit and right-sided limit different? Let me show you an example here. Now, this is piecewise functions. The function defined piece by piece. So I have two pieces here. When the x is less than or equal to -1, we use this one. When the x is greater than -1, we use this one. So that's why you have two pieces of graph here. So how about if I ask you to find the limit of this function f of x as x approaches -1? Okay, so now let me break it become two parts. The limit of this function as x approaches -1 from the left hand side. So I put a small minus sign here. It means that from the left hand side. Okay, what is the answer? You try look at the graph. From the left hand side means this way. Okay, let me use another color. Heading to approaches -1 from the left hand side. You will notice that the y heading to 2, right? So the limit, the left-sided limit is 2. This is equal to 2. This is left-sided limit, or we call it left-hand limit. So how about the limit of f of x as x approaches -1 from the right hand side? Let me put a positive sign here to indicate that this is the limit as x approaches -1 from the right hand side. From the right hand side, you notice that the y is heading to this value, which is equal to 3, right? Which is equal to 3. In this case, you will notice that from the left hand side, the left hand limit or left sided limit and right sided limit, they are different. When x approaches -1 from both sided, the value of f of x approaches to a different value. Left hand limit is equal to, or we call it left sided limit is equal to 2. Right sided limit or right hand limit is equal to 3. In this case, if the question asks you to find the limits of this function as x approaches -1, doesn't mean the question does not tell you from the left hand side or right hand side, or we can call it both sided limits or overall limit. In this case, the limit does not exceed. D and E stand for does not exceed. Okay, because they are heading to the different number. Okay, now let me show you a few more example. How do we get a limit of a function as x approaches a finite number? This one, if you are still not clear, right, you can try to rewatch my video again or try to pause it, think again. You will see a negative sign here, but now you will not see this. I just explained to you. When the left hand limit and right hand limits, they are different, or the left sided limit and right sided limits, they are different, means that the overall limit or both sided limits does not exceed. Okay? Okay, let's look at these 7 different situations. See how do we get the limits of that function as x approaches a finite number. Okay, let's try the first one. Let me use red color. the limit of this function 2x plus 3 as x approaches 1. Okay, it means that when x closer to 1, what's the value of f of x heading to? So normally we will try direct substituting first, because this is the first attempt, normally the first method that we use. We try to plug in the 1 over here. Once I plug in 1, when I substitute the 1 inside, I don't have to write this anymore. 2 times 1 plus 3. So it's equal to 5. Okay, this is very simple. This one we call it direct substituting. Okay, so how about the second one? Let me copy first. Limits of this function x squared minus 2x plus minus 8, x squared minus 16 as x approaches 5. Okay, same thing. We try direct substituting first. Plug the 5 inside. So I will get 5 squared minus 2 times 5 minus 8. So 5 squared minus 16. So this is 25. So this is 10. You can just press your calculator. So this is 8. Sorry. Let me check again, correct or not. My equation should be correct. Okay, correct, no problem. So the answer is this is 15 minus 7. So this is 9. Okay. Now let's try part 3. The limit of x squared minus 2x minus 8 over x squared minus 16 as x approaches 4. Okay, same thing. The first method normally we use is a direct substituting. If no problem, then we can get the answers. If we have a problem, then we have to try another method. So I just tried direct substituting first. Plug in the 4 over here. You get 4 squared minus 2 times 4 minus 8. And this is 4 squared minus 16. So here you will get a 0. Here you get 0 as well. This is indeterminate form. Indeterminate form. So it means that this is not the correct way for us to solve these questions. We need to try another method. Okay, as I copy in the question, you can try to think what is the method that you can use, or you can try to pause the video and try on your own. So I'm going to factorize this part. Okay, so here I can factorize this. To do the factorization, you can use a calculator if you want. So this is 4, this is 2, this is negative, positive. Okay, let me check, correct? Here I can do the same thing. I hope that you remember this. Right? Okay, so how about I do one more step? This one I just copy first. A squared minus b squared. You know that we can write a plus b, two parentheses, one is a plus b and then one is a minus b, right? Oops, sorry, this is 4. Okay, this is 4. Let me check, correct or not. Okay, now you notice that I can cancel up the x minus 4, right? So I just cancel up the x minus 4, simplify it. Now I will get x plus 2 over x plus 4. I still need to copy this. X plus 2, x plus 4. Okay, now if I direct substitute this 4 inside, no problem, right? So now I'm going to plug in the 4 over here. One, I bring the 4 inside here. I don't have to write this anymore. 4 plus 2, 4 plus 4. 4 plus 4. Okay, so this is 6 over 8. I simplify it, I will get 3 over 4. Okay, so there's a way how we solve this questions. Actually, you can also use your calculator to help you if you want to check whether your answer correct or not. Okay, first you just key in this whole thing inside. X squared minus 2x minus 8. Then this is x squared again, x squared minus 16. Okay, make sure we key in correctly. Okay, then you press this calculate. So your calculator will ask you what's the value of x that you want to use. If you plug in 4, you cannot get the answer. You get equal, you get math error, right? So we're going to plug in a number really close to 4. So how about we try 3.99999. 3 point. Okay, we press a lot of 9. So make it become closer and very close to 4. Press equal. Okay, still get max error. So how about we try? Should be able to get the answer. We reduce the number of 9. Okay, see whether I can get the answer or not. Yes, now we get the answers. We got the answer, which is 3 over 4. Okay, but using the calculator, sometimes we cannot get the answer. So how about I try 4.0001. This is from the left hand side, right? Now how about from the right hand side? I change the value to 4.00001. Okay, try. We got the answer as well, which is 3 over 4. Okay, this is a way how we use the calculator to help us check our answer. Okay, so this one I think majority of you should be no problem. You know that you plug in a 0 here, and 0 here you get indeterminate form, right? So we know that we cannot use direct substituting. So what we can do is we factorize first. Factorize x. Then we can cancel up the x. So I have x plus 3. Now I can put it 0 inside. Once I substitute the 0 inside, I don't have to write this anymore. So the answer is 3. Okay, now let's look at question number 5. Same thing here, you notice that the product is 0 here, you get 0. The denominators of a fraction cannot be 0, right? So how do we solve it? In this case, normally the x here will be able to cancel up at the end. So we try to change the denominator of the fraction here the same first. Here I times 4, times 4. Here I times x plus 4, x plus 4. So I will get 4 over, okay, 4x plus 4. So here I will get x plus 4, 4, okay, x plus 4. Over, it looks quite complicated, right? Okay, let me check correct or not. Okay, should be no problem. So now I just combine these two fractions together since they already have the common denominator. So you just have to be more careful here. You have a negative here. So 4 minus x minus 4 over 4x plus, okay, 4x plus 16. So divided by x, I can change become 1 over x times 1 over x, the same thing. Okay, if you want, you can put a parenthesis here. If you don't want to put a parenthesis, okay. Okay, so 4 minus 4, you will eventually cancel up the 4. So you have negative x over 4x plus 16. Now we can cancel the x. Here and here cancel up. Okay. So the next step, we still need to copy this. Negative 1, 4x plus 16. Okay, now I'm going to substitute the 0 inside here. Once I substitute the 0 inside here, I don't have to write this anymore. So the answer is 4 times 0 is 0, so it will be negative 1 over 16. Okay, now let's look at question number 6. Same thing here. If you plug in the 0 here, we get 0 as the denominator. We know that there's not a correct way, right? So how about we do some expansion here? X squared minus 6x plus 9. If you don't know how to use a formula, you can do it this way. Times multiply 1 by 1. You will still get the answer, this answer. Okay. Let me go erase this one first. So the positive 9 and negative 9 will actually cancel up, right? So you will left x squared minus 6x. I bring the x outside, factorize the x, I will have x minus 6. Okay, so eventually I can cancel up the x here. Now I'm going to substitute the x equal to 0 inside here. Once I substitute the x equal to 0 inside here, I don't have to write this anymore. So it's equal to negative 6. If you want to use a calculator and check your answers whether correct or not, you can try. Okay, let me key in this one first. X minus 3 square minus 9 over x. Okay, then you press the calculate button. Calculator will ask you what is the value of x that you want to use. You cannot use 0. If you use 0, right, you get math error. We need to use a number which is really close to 0. How about we use 0.000. Okay, let me press a few 0 here. Okay, this is really close to 0, right? Press equal. Okay, we got the answer, which is equal to negative 6. Okay, let's try the last one. Okay, same thing happened here. If you plug in the 5 over here, you get indeterminate form, right? So we know that that's not the correct way for us to solve this question. So we are going to rationalize the numerator first. Let me copy first this one. X minus 5. Okay, I have to times the I want to rationalize this numerator. I want to times multiply this by its conjugate. So it means that everything you copy, you just change the sign here. X plus 4. Here's the same thing, so you're using the same symbol. Just this one you change it, become plus. Okay, whatever you do for the numerator, you have to do the same thing for the denominator. Okay. Now, a minus b, a plus b. You know that this is actually a squared minus b squared, right? So this is a squared minus b squared. If you don't want, you want to multiply 1 by 1, you can do it like this. You get the same answer. So this actually, oh, let me write again here. A squared minus b squared over, okay, this one, let me check. Okay, let me keep it first. So this will be x plus 4 minus 9. And here I will have x minus 5, then square root of x plus 4 plus 3. Okay. X plus 4 minus 5, minus 9, you will get x minus 5 square root x plus 4 plus 3. Okay. Now, the x minus 5 we can cancel out. Cancel this up. Okay, so eventually we left limit as x approaches 5, and this is 1. So this square root x plus 4 plus 3. Okay, we are going to get the answer soon. Now I'm going to substitute the x equal to 5 inside here. Once I bring the 5 inside here, we don't have to write this anymore. 5 plus 4 square root plus 3. So this is 9. Square root of 9 will give you 3. 3 plus 3 will give you 6. Okay, let me check my answer correct or not. Yes, correct. So this is a way how we solve the question involve the limits of a function as x approaches a finite number. Okay, that's all for this video. See you next time. Bye bye. Thanks for watching. Bye bye.